Okay, so in this next problem we are asked to sketch the graph of the function, and the function we're given is f of x equals the negative greatest value integer of x. So what I'm going to do is I'm going to start off in plotting the simplest points, or at least what I think are the simplest points, and I'm just going to plug in integers for x. So for example, when f equals, or at f of 0, we're going to have negative the greatest value integer of 0, the greatest value integer less than or equal to 0 is 0. So then we have negative times 0, which is just 0. So that means we can plot a point at 0 like this. And then at f of 1, we're going to have negative the greatest value integer of 1, and the greatest value integer less than or equal to 1 is 1, so we're going to have negative 1, so we're going to go down to 1 comma negative 1, and because there's no real slope, nothing is being multiplied in here that's larger than 1 or negative 1, we know that our slope is going to be negative 1. So for example, 2 will be 2 comma negative 2 will be our ordered pair. Same thing with 3 comma negative 3. And you can go ahead and plug in these points for yourself just to make sure. I'm going to stop at 3, and then I'm going to go to negative 1 now. So when we do f of negative 1, we're going to have negative times the greatest value integer less than or equal to negative 1. And the greatest value integer less than or equal to negative 1 is negative 1. So we're going to have negative 1 times negative 1, which is positive 1, meaning our ordered pair is going to be negative 1 comma 1. And then we're just going to follow that same pattern. So we're going to have negative 2 comma 2 and negative 3 comma 3. Now the question is, for the greatest value integer, we know that it looks like this, one point looks like this, and then there's a line and it goes to an open circle where it's not inclusive. So we need to figure out where that open circle goes, because it could go like this, in this direction, or it could go like this. So we want to figure out which way those open circles are going to be. So now I'm going to plug in some non-integer points. So I'm going to start with f of 1/2. So that's going to be negative the greatest value integer of 1/2. And the greatest value integer that's less than or equal to 1/2 is 0. 0 is less than or equal to 1/2. And so we would get 0 again for this. And so we can see up until we get to 1, all of these points will default back to 0. At f of 1/2 it will be 0. At f of 0.3 it will be 0. At f of 0.789 it will be 0. But at f of 1 it will jump down to this point. So our open circle is going to look like that. It's going to be the open circle is going to be to the right of the closed circle. And again, you can plug in these points for yourself and you should see the same thing. So it would just look something like this. And that's how you do that one. Alright, so in this next question we are once again asked to sketch the graph of the function, and this time our function is g of x equals the greatest value integer less than or equal to x minus 2. So the first thing I'm going to do is I'm just going to plot some whole integer points as if we were plotting a normal graph. So for example, if I make this table here, and I have one column for x and one column for y, and let's say I plug in 0 for x, well, the greatest value integer that's less than or equal to 0 is 0. So 0 minus 2 is negative 2. So we have the point 0 comma negative 2. Now I can do 1. The greatest value integer less than or equal to 1 is 1, and 1 minus 2 is negative 1. So I'm going to have the point 1 comma negative 1. And if we go one more to the right to 2, the greatest value integer less than or equal to 2 is 2, and 2 minus 2 is 0. So we can go to 2 comma 0, and we can see here that our line looks like it has a slope of 1. So we can extrapolate this further and say that we have a point at -1 comma -3, and we can even go one more to the left and say that we have another point at -2 comma -4. So now we have these points, but we want to know whether our line is going to go like this or whether our line is going to go like this. So in order to do that, let's plug in a non-integer point. Let's plug in 1/2. If we plug in 1/2, the greatest value integer less than or equal to 1/2 is 0. And as we know from here, 0 minus 2 is -2. So that means for every non-integer value between 0 and 1, it's always going to default back to -2. So if we plugged in 1/4 for x, or if we plugged in 1/6 or 1/100th, or anything that's a non-integer value between 0 and 1, we're going to find that our point is going to be at -2. Our y point will be at -2. And then as soon as we get to 1, then it's going to jump up here. So we can say that our line is going to look something like that. And then we can continue the pattern, and we can say that our graph will look something like this. And that's how you do that one. Okay, so in this next question we are asked to do the exact same thing, except this time our function is g of x equals the greatest value integer less than or equal to the sum of x plus 1. So once again, I'm going to go ahead and make our table here with x and y, and we're just going to go ahead and start by plugging in some integer values. So if I plug in 0, 0 plus 1 is 1, and the greatest value integer less than or equal to 1 is 1. So I have the point 0 comma 1. And then if I plug in 1 for x, then I have 1 plus 1 is 2, and the greatest value integer less than or equal to 2 is 2. So we have 1 comma 2. And we can even go one further to the right and say 2 plus 1 is 3, and the greatest value integer less than or equal to 3 is 3, giving us the point 2 comma 3. And once again, it looks like we have a slope of 1, so I can go ahead and finish the pattern here going to the left. So we have these points here, but how do we know if it goes like this or like that? In order to find out, I'm going to plug in a non-integer value, and once again I'm going to plug in 1/2. So if we plug in 1/2, 1/2 plus 1 is going to be 1.5, and the greatest value integer less than or equal to 1.5 is 1, meaning that between the points 0 and 1, no matter what we plug in, it's always going to default back to this y value of 1. For example, if we plug in 1/16, then we get 1/16 plus 1 is 1 1/16, and the greatest value integer less than or equal to 1 1/16 is still going to be 1, meaning that our lines are going to look something like this. We're going to have our open circles on the right here. And that's how you do that one. Okay, so in this next question we are asked to graph the function, and the function we're given is a piecewise defined function that's defined as 2x plus 3 when x is less than 0, and as 3 minus x when x is greater than or equal to 0. So I'm going to start off with graphing, let's start off with 0 first. Let's plug in 0. So if we plug in 0, we'd be going to this 3 minus x function, because it's when x is greater than or equal to 0. So 3 minus 0 is just going to be 3. So we have that right there. And then if we go greater than 0, 3 minus 1, for example, is 2. And if we plug in 2, 3 minus 2 is 1. And so really this is just going to be a negative slope. It's just going to be a linear function with a slope of -1. So it's going to look something like that. Now for this one, 2x plus 3, if we plug in -1 for x, 2 times -1 is -2, plus 3 is 1. And then if we plug in -2, 2 times -2 is negative 4. Negative 4 plus 3 is negative 1. Then if we go to negative 3, for example, 2 times negative 3 is negative 6, and negative 6 plus 3 is negative 3. So we can go down here to negative 3. And so what we see here is we have another linear function, but this one has a slope of 2, so it's going to be a little bit steeper, but it's going to look something like that. And then if we want to, we can graph what this up top function might be when it is 0, but we would have to draw an open circle around that to indicate that it doesn't include 0. So for example, if we were to plug in 0 for x into this equation, 2 times 0 is 0, and 0 plus 3 is 3. So we could draw it like that. That was a bad drawing, but we can draw it like that, but we would put an open circle around it to say this does not include this point right here, because this is only defined when x is less than 0. So that's how you do that one. Okay, so in this next question we are once again asked to graph the function, except this time our function is again piecewise defined, but defined by different functions. So it's defined as the square root of the sum of 4 plus x when x is less than 0, but then it's also defined as the square root of 4 minus x when x is greater than or equal to 0. So let's start out with the point of 0 here. If we plug in 0 for x, then we're going to default to this bottom equation here, this bottom function, because it says when x is greater than or equal to 0. And because we're plugging in 0, we would get 4 minus 0, which is 4, and the square root of 4 is 2. So we have a point 0, comma 2. So then let's plug in another point. Let's try 3, for example. Now 3 is greater than 0, so we're going to go to this bottom equation here. 4 minus 3 is 1, and the square root of 1 is 1. So now we have the point 3, comma 1. And then if we plug in 4 for x, 4 is greater than or equal to 0, 4 minus 4 is 0, and the square root of 0 is 0. So we would get the point 4, comma 0, and our line would look something like this. And it would actually end here as well, because if we plugged in 5, for example, we'd get 4 minus 5, which is the square root of negative 1, which is an imaginary number. And because we're not dealing with imaginary numbers yet, we can't plug that in. Now if we go to the opposite side of the spectrum, for example, and we plug in something like negative 5, well, 5 is less than 0, so we're going to go to this top equation here. So now if we plug in something like negative 3, for example, negative 3 is less than 0, so we could do 4 plus negative 3, which is 1, and the square root of 1 is just 1. So we'd get negative 3, comma 1. And then if we were to plug in something like negative 4, we would get negative 4 plus 4 is 0, square root of 0 is 0, and we would get negative 4, comma 0. And so we can see here, if we were to plug in 0, for example, and go to this top equation just to see where it would be at, we could say 4 plus 0 is 0, or 4 plus 0 is 4, and the square root of 4 is 2. So we can make our line like this, but then when we get to the y value of 2, we can make an open circle for this graph to indicate that includes all values except for 0. It includes like negative 1/2, negative 1/4. It includes every value going up to 0 except for 0, and then it stops at 0. So that's how you would do that one. Okay, so in this next question we are asked to graph the function again. This time our function is still defined in pieces, but the pieces are different. So it's defined as x squared plus 5 when x is less than or equal to 1, and it's defined as negative x squared plus 4x plus 3 when x is greater than 1. So right now I'm going to make a table of values, and to start I'm going to plug in 1 for x. Now if I plug in 1 for x, we're going to go to this top equation right here, because 1 is less than or equal to 1. So we plug in 1, we're going to get 1 squared plus 5, 1 squared is 1, and 1 plus 5 is 6. So we know we have the point 1 comma 6, so we go up 6 to about here. Then if I plug in the point 0, 0 is less than 1, so we go to the top equation again. 0 squared is 0, and 0 plus 5 is 5. So we have 0 comma 5, so I'm going to go up 5. And now we can see that this top equation is the equation of a parabola, meaning it's going to be symmetric about the y-axis. So I can just reflect this point like this. And we can see if the parabola continues, it would just keep getting wider and wider like that. And then here it would stop right there, because past 1 we would go to this bottom equation here. So if we plug in 2, for example, we're going to have negative 2 squared plus 4 times 2 plus 3. And 2 squared is 4, so we have negative 4 plus 4 times 2 is 8. And that's going to be plus 3. Negative 4 plus 8 is 4, and 4 plus 3 is 7. So we have 2 comma 7 right there. So we can go to 2 and like this, 2 comma 7. And then if we go to 3, for example, if we plug in 3 for x, we're going to have negative 3, oh, wrote that wrong. We're going to have negative 3 squared plus 4 times 3 plus 3. 3 squared is 9, so it's going to give us negative 9 plus 4 times 3 is 12 plus 3. Negative 9 plus 12 is 3, and 3 plus 3 is 6. So we'll have the point 3 comma 6, so it's going to be 3 comma 6 like that. And now I'm not going to continue the graph, but if you were to continue graphing it, it would look something like this. And then of course if we plug in 1 into the bottom equation, we would get negative 1 squared plus 4 times 1 plus 3. 1 squared is 1, so we have negative 1 plus 4 plus 3. Negative 1 plus 4 is 3, and 3 plus 3 is 6. So we can do an open circle around 6 here to make sure that on this equation to the right here, it contains every value up to but not including 1, or it includes every value greater than but not equal to 1. So that's how you do that one. Okay, so in this next equation, in this next question, we are asked to graph a function, and this time we're given another piecewise defined function, but this time it's actually defined in 3 pieces, which we haven't seen before. So the 3 pieces that define this function are 4 minus x squared when x is less than negative 2, 3 plus x when x is between negative 2 and 0, and x squared plus 1 when x is greater than or equal to 0. So right off the bat, I'm going to go ahead and just make a table of values and start plugging in some points. So I'm going to choose a plausible left-hand value that we could do. So we want to go something that's less than negative 2. So just to make it easy, let's go negative 3. So if we plug in negative 3, we're going to go to this top equation here, and then we're going to have 4 minus negative 3 squared. That's going to be 4 minus 9, which is negative 5. So we're going to have the point negative 3 comma negative 5, which is down here right about. Now I'm going to plug in the point 2, negative 2 for example. I'm going to plug in the point negative 2, and I'm still going to plug it into this top equation just to see where my line is going, because I don't know which way it's going based off of this one point. So if we plug in negative 2 to this top equation, I'm going to have 4 minus negative 2 squared. Negative 2 squared is 4, so that's 4 minus 4, which is 0. So I'm going to have an open circle at the point negative 2 comma 0. And the reason that is because this equation is not defined at negative 2, or yeah, it's not defined at negative 2. It's defined at every point that's less than negative 2, but it's not defined anywhere it's not defined at -2 or any value greater than that. So, and because this is I can tell by this equation that it's a downward opening parabola, I know it's going to have some sort of curvature to it like that. But again, this is an open circle because I want to specify that this top equation does not include -2. What does include -2 though is this middle equation. So we plug in -2 to the middle equation, we're going to get 3 plus -2, which is 1, giving us the point -2, 1. And that is going to be a closed circle because this is defined at -2. Then if we plug in -1, -1 is between -2 and 0, so we're going to use this middle equation again. That's going to give us 3 plus -1, which is 2. So we know that we have the point -1, 2. So I can go -1, 2 like this. And this is a linear equation, so and it has a slope of 1. So if I were to go to the right one more value, we'd have the point 0, 3. And if I wanted to test that out, I can plug in 0 to the middle equation, and 3 plus 0 is indeed 3. But because this equation is not defined at 0, because it's just less than 0, it's not less than or equal to 0, we have to draw an open circle at the point 0, 3. And then we can do something like that. Now if we go to, if we plug in 0 and we want to have a defined point, we would plug it into the bottom equation here, x squared plus 1. So we would have 0 squared plus 1, and 0 squared is 0, and 0 plus 1 is just 1. So we'd have we'd have the point 0, 1, and then if we plugged in another point, we'd like 1 for example, 1 squared is 1, and 1 plus 1 is 2. So we'd have the point 1, 2. And because this is a parabola again, we know it would just go up and up and up, curving like this. So that is how you do that one.